Okay. All right, so here we go. So welcome to Honors Pre-Calculus. So what we're doing today is just the last day of Trig Proofs, the last day of proving trig identities. We did an icebreaker. I'm going to have you all try a warm-up. I'm going to give you some reminders, some do's and don'ts of what to do when you're writing trig proofs. And then the last 20 or so minutes of class, or we'll see how long we have, you'll have time to work on the week 9 formative, which is, or you can work on the week 9 homework, whichever you need to do. So that's your homework. It's not due tomorrow. Some people said that the original due date was tomorrow. So thank you for telling me so I could fix it. The due date is actually next Wednesday. Okay. Calls are starting to go home. If your grades are an E, please make sure you get your assignments done. I've started to make some emails and phone calls home. So please get those assignments up as soon as you are able to do it. The marking period ends a week from today. So please don't wait till the last minute. It's going to be stressful. Please do maybe like a couple of assignments each day if you can, and let me know if you need support. Okay. All right, so for your warm-up, this is going to be your warm-up verifying trig identities. So please verify that secant y divided by cosine y minus tangent y divided by cotangent y is equal to 1. Okay, so please go ahead and do that in the draw it slide, which is the next slide. And you can go ahead and get started whenever you're ready. I'm going to give you about 3 minutes to verify that those are equal. Oh no, good question. Someone asked if I graded the progress check. The makeup is tomorrow, so I'm going to grade them after tomorrow. I'm going to grade them tomorrow. All right, so go ahead and get started on that warm up. Okay. I loved your answers. I like how people did different stuff. So I'm going to share a screen. I hit everybody's name so that hopefully nobody is going to feel like they got singled out. Okay, so there are like a couple different things that people did. So I want to highlight this because this is pretty cool. So this person said, okay, well, secant y over cosine of y is the same as secant y over 1 over secant of y, which puts 2 secants in the numerator, right? And then tan over 1 over tan is just tan squared. And then they used, this is so cool, they used a Pythagorean identity that 1 plus tangent squared equals secant squared to prove that this is the case. Because yeah, secant squared minus tangent squared is 1. That's a Pythagorean identity. Bam. 100%. Okay. So that's one way to do it. There's another way to do it. So what this person did was they said, well, let me see if I can get like see what my denominators look like. So secant is 1 over cosine. So that's 1 over cosine. And then tangent sine over cosine over sine. So they notice that this has the same denominator. These two terms, if you break it down into sine and cosine, they have common denominators, which is cosine squared of y. And then if you put the two numerators over that same denominator, you have 1 minus sine squared of y. And then you get that Pythagorean identity that 1 minus sine squared is cosine squared over cosine squared is 1. So I just think it's really cool how people came about it in different ways and with different styles, but both ways are totally valid. And what I absolutely love about the way that people answered this is that it just reveals that there is more than one way to do these proofs. Okay, so excellent job, excellent work. Okay, so excellent work, everybody. So questions about the warm-up? All right. So excellent work, everyone. Nice job. This is just another way to look at it. Let me just go ahead and share again. Okay, so this is another way to look at it, and this is like the sort of when you get if you get desperate and you just have no idea what to do, how do you approach it? So if you get super stuck, you can always break these all the way down into sine and cosine, right? So secant I highlighted in yellow because what I wrote below was just the same thing but in yellow. Cosine in the denominator, so 1 over cosine is 1 over cosine squared. This orange here, the tangent of y, that's sine over cos, and then a cotangent in your denominator is going to be sine over cosine. Okay, so I have 1 over cosine squared minus sine squared over cosine squared. I can smush those together over the same denominator and use my Pythagorean identity to show that it's cosine squared over cosine squared, which is just 1. Okay, and I'm excited. I'm excited to be able to say that, right? Okay. All right. So just some reminders, okay? So just remember to start with a more complicated side, okay? Just like I did in my demonstration of the warm-up, if you get really stuck, you can always change everything to just sines and cosines and just see like what you can put together, what you can cancel. That's always an option for you if you really get stuck. But use your identities when you can, because it's going to make life a lot easier, okay? Okay. So I want to do, now that I've seen a couple of your homeworks, I want to do some do's and some don'ts. Okay, because I'm seeing a lot of this in the warm-up and on your homework. So with, like, let's take this for example. We have, this is tan x sine x. Prove that it equals secant x minus cosine of x. Okay, I'm going to start on the right because I like the idea of just being able to combine these terms. Okay, so what I'm going to remind you to do is stay on one side. Don't start dividing both sides by anything or subtracting. Just stay on one side. This is not solving equations. This is not finding a solution. We stay on one side of the equation until it looks like the opposite side. That's what a proof is. Okay. All right. I'm also going to kind of really painstakingly go through my steps. So I'm going to break this down. I'm going to say secant is 1 over cosine. Cosine is just cosine over 1. Okay, so I'm taking that, breaking that down. Okay, I'm going to get the same denominator. So I'm going to, maybe I'll just do cosine times cosine over cosine, because now I just have common denominators. So that'll be 1 minus cosine squared of x over cosine. That's actually sine squared of x over cosine. So sine over cos is the same as, because this would be a tan of x sine of x. And now I've proven it. So my other do here is show every step. Every step. If you show this to someone else in class, the other person in class should be able to see how you arrived at your conclusion. Okay, it's not about getting the right answer, it's about showing your process. So make sure you show every step, okay, and be able to explain it. Okay, this is extra and you don't have to do this. Let me type. This is optional, but it helps to kind of bolster your argument. Say what you did for each step. So this is not something that you necessarily are going to like be required to do, but like, you know, here I say, you know, I put common denominators, right, for this first one. Can I make this smaller? I can, right? No, it's just going to make it bigger. Okay, there we go. Now it's smaller. So like in this step is common denominator, right? And then in this next step is a Pythagorean identity. Sine squared of x plus cosine squared of x equals 1, and right, and so forth. And then this is, you know, your tangent identity. So this is optional, right? You don't have to do this, but again, the idea is that you're explaining why this is the case. You are not like, you know, solving an equation. You're explaining why it's the case. So these are like some do's, okay? Some don'ts, okay? Don't just write true. Please do not do that, okay? That is like you don't get any points answer for that one, okay? Because it is true, and that's why we're giving it to you as a proof. But your job is to show that it is true. Show every step. And if possible, say what you did for each step. Okay, don't just write true or yes, it equals. Also, by the same token, don't just write the next expression. I saw some people do it on their homework. So if they were given this problem, don't just rewrite the equation or one of the expressions. Okay, that's not really showing me that you're demonstrating the understanding and mastery of what this is, right? You want to show your steps, okay, and you want to prove to me and the reader why this is true, okay? All right, any any questions about that for now? And I'm gonna put this on the slides so you can look at it later. But any questions about that? All right. Okay, so what I want to give you now is about 20 minutes or so to work on either your homework or your formative. You can ask me questions if you have any. And if you're having trouble accessing the Nearpod for whatever reason, here are the links to the formative. Links to your choices. You can either work on the formative or you can work on the homework. So, and you can ask me questions as you work too, just, you know, chat them or unmute yourself. Okay, so that is time. Someone did ask to go over C, so we can do that. All right, and I don't want to do the whole thing. I just want to kind of help get you a little bit started on it. So I want to make sure you saw that. Remember, I said this at the beginning of class, but I want to say it again. We had to change the denominator. The original denominator here was 1 plus cosine. It has to be 1 plus sine, otherwise it won't work. Okay, so definitely make sure that you have that. All right. Okay, so I would start with the left side. The left side looks a little bit more unwieldy, right? So we see that the left side has 2 terms and the right side has just 1 term. Okay, so basically I have to condense this left side into 1 term. And the best way to do that is to think, okay, let's think about if we can think about common denominators. Common denominators. Okay, so if I multiply the left side by the denominator that the right side has, and the right side by the denominator the left side has, it'll be the same. Okay, so let me do that. I'm going to recopy the expression just as it is, over 1 plus sine of x plus 1 plus sine of x over cosine of x. And I'm just going to multiply by the other denominator as a form of 1, right? So I'm going to do cos of x over cos of x. And then here I'll do 1 plus sine of x over 1 plus sine of x. Okay. Haven't broken any laws. I'm just doing a denominator. And let me go ahead and simplify. Let me put this all over 1 in one fraction, right? Because now they have the same denominator, yay. That makes me happy. So here we go. So they have the same denominator. Cosine times cosine, just cosine squared of x plus, and then I'm going to go ahead and FOIL this, right? I'm just going to FOIL this expression right here, 1 plus sine times 1 plus sine. So that should be 1 plus 2 sine plus sine squared. Okay, so it's just like that double distribution that you guys did in algebra 1 and algebra 2. First, outside, inside, last. Okay. So I can write here, maybe if you wanted, this is extra, you don't have to do that. You don't have to write your steps, but I'm going to write them out. I'm going to write distribute. Okay. And now I can look, so I don't want to distribute the bottom though. I don't want to distribute the bottom because see how my end goal is 2 times secant of x? Secant is 1 over cosine. So I want to leave the bottom untouched to see if I can get the 1 plus sine to cancel and just have cosine in my denominator. Okay. So cosine squared plus sine squared, what does that give me? What does that allow me to, what can I do with that?
E equals 1.
Yeah, very good. Thank you. And I didn't see who that was. Was it Ibrahim? Thank you. Yeah, this is a Pythagorean identity. So I can actually change that to 1 and then write the rest of my expression. 1 plus 2 sine x over cosine of x times 1 plus sine of x. So that's just using that wonderful Pythagorean identity that we love. Pythagorean identity. Okay. So now I have 2 plus 2 sine of x, because I am going to add these ones together, over cosine of x plus times 1 plus sine of x. Okay. And I'm not going to finish the problem for you because I want you to complete it, but I will give you a hint, which is that 2 plus 2 sine of x has a GCF, a greatest common factor of 2. Okay. All right, so other questions, either about the homework or a technique or anything like that? right, so question D, sure. Sorry, I have two Zooms running, and the one that I'm actually sharing screen on isn't showing your chat, but the other one is. Okay, so we can talk about letter D. So let's do that. So letter D has sine squared of x plus 4 sine of x plus 3 over cosine squared of x equals 3 plus sine of x, 1 minus sine of x. All right, I'm going to start on the left because the left is pretty gnarly. And I'm trying to get 3 plus sine and 1 minus sine, right? So basically, I want to disappear the cosines in this problem. So the numerator has sines, so that's fine. Is there a way that I can rewrite the denominator, but just in terms of sine? Anyone have any ideas? Is there a Pythagorean identity that we know and love? Yep, someone's got it. Yep. Very good. Thank you, Tobias, and some other people who chatted privately. So yeah, so I could rewrite the denominator as 1 minus sine squared because that's my wonderful Pythagorean identity, okay? And I can just, if you know, I can leave. You can do multiple steps at once. I just I need to see the logical progression. Okay. All right. So this is just the Pythagorean identity. Pythagorean identity. All right. And now what I need to do is I need some things to go away because look at the right side. It's so much simpler. Okay. What can I do with either the numerator or the denominator to, you know, like I have these quadratic terms and I don't want them because I want only linear terms. Are there any strategic ideas that you all have that we can do? Someone chatted privately for the denominator. That the denominator could be just written as 1 plus sine of x times 1 minus sine of x. So that's going to be helpful because look, I see that I have 1 minus sine of x here, so that might be a winner. Okay, so this is just factoring. But what can I do with the numerator though? Is there anything I can do with the numerator? I'm checking both chats. How do I get, what do I do with sine of x squared plus 4x plus 3? Okay, what if I, just kind of a thought bubble here, just like this thinking. So this is a sine, but what if I just had like m squared plus 4m plus 3? Can I do something with that? Yeah, thank you guys. And yeah, thanks Tobias. So yeah, you can factor this. This is a binomial and you can factor it as m plus 3 times m plus 1. Okay, oh, it's like terrible handwriting. Let me rewrite it nicely. You can factor this as m plus 3 times m plus 1. Okay, so it stands to reason you could do the same thing with sine, right? You could factor sine in that same manner, right? Sine, oh, well, that's fine. Sine of x plus 3 times sine of x plus 1. So we actually, the only two things we've done are Pythagorean identity right? Changing that cosine squared into 1 minus sine squared, and then factoring the numerator, like your old algebra 1 factoring, and then factoring the denominator with that algebraic identity factoring, okay? And then from there, you can see that actually these two terms, or these two expressions, why didn't it change color? These two expressions match. So those are going to divide out, and I think you all should be able to do the rest.
Good afternoon.
Ooh, announcements.
It was so good to have staff and students back in the building today. I'm really looking forward to having you back tomorrow.
Okay, so any last questions about this problem?
One more thing before we ring the bell.
All right, any last remaining questions? All right, so just remember to come to study hall tomorrow if you haven't taken the progress check. It's 10 points, so please make sure you come. And then just remember you have one more week to do all of your assignments. So please make sure that you don't delay, do everything you're supposed to do. And I hope you guys have a great day. Bye.